You did some really lovely experiments showing that if people who have low levels of dopamine increase their dopamine pharmacologically, I think the drug that was used was bromocriptine, that working memory improves. Conversely, if one depletes dopamine pharmacologically, working memory gets worse. But as I recall, there was an important baseline that is important because it really mattered in terms of the outcome. Meaning if somebody already had relatively high levels of dopamine in this circuit, increasing dopamine further with bromocriptine didn't impart a benefit and might have even made their working memory worse. So there's a kind of inverted U-shaped function to this. How does one know whether or not their baseline dopamine is low, medium, or high? Ergo, how do they know whether or not they would want to explore going about increasing dopamine through any number of different approaches?
Right. Well, most people probably have optimal dopamine, but there's a significant percentage that probably have too little or maybe too much. And unfortunately, we can't measure it in the blood. There isn't a blood test that I'm aware of that can measure dopamine because it's stuck in the brain.
Peripheral dopamine in the blood is not a good readout.
Is not a good readout, yeah, and especially when you're talking about dopamine in areas like prefrontal cortex, and so we don't have a good readout there. There's invasive procedures like positron emission tomography where we can inject a radioisotope and that tags dopamine, and then we can measure how much. We can do a scan that actually shows us how much dopamine. This scan was originally developed to show Parkinson's disease, that you can diagnose Parkinson's disease by showing that there's less dopamine in patients that have Parkinson's disease by looking at this scan. Obviously, it's invasive. You're injecting a radioisotope. It's expensive, and it's not something we could all do. But we had used it to show that it correlates very strongly with your working memory capacity. So how much information you can hold online. If you can hold 4 or 5 or 6 letters when I do a span task, correlated with how much dopamine we can see in the PET scan. So that would be a way that we could do it.
So if you were to read out a string of a few numbers or letters, and I can remember all of those a few moments later, perhaps my baseline dopamine levels are moderate in the normal range. Whereas if I couldn't keep that online, that might be reflective of lower baseline dopamine levels. Is that right?
Yeah, it's a very strong proxy for dopamine. So if your working memory capacity is 7 letters or numbers, when I say 4, 3, 7, 1, 5, 0, 6, if you get the
4, 3, 7, 5, 7,
get
6,
them all
right?
back to me pretty quickly, you probably have more baseline dopamine than someone who has 5. So it's a proxy for measuring someone's dopamine. So that's one way of doing it, and that's actually how we did it in our original studies. We actually grouped individuals based on whether their capacity, based on this behavioral measure, was high or low. And like you said, those that could only hold 5 or 6 letters, if we gave them bromocriptine, which was the dopaminergic agonist, we improved their working memory. We got them into sort of an optimal level. But those who were already high, we actually made them. We got them worse. And the moral of that story was that more is just not better. We're trying to get people optimal. And so the real question is if we want to get people optimal, like you were inferring, you have to know what their dopamine is. Where are you on this inverted U curve? Another way of doing it is through genetic studies. So we have dopamine. All neurotransmitters have to be broken down and reuptaked into the brain cell in order to be used again. And there's different ways of doing it. In some cells, it gets transported back into the brain cell, and other places there's an enzyme that breaks it down. Well, there's an enzyme called COMT that breaks down dopamine in the prefrontal cortex specifically. In a large percentage of individuals, that enzyme is either overactive or underactive. Probably about 25% of individuals, it's overactive, and another 25% it's underactive. So probably half the population. Now, this is going to depend on where you live and where you come from and things. But maybe half the population either has an underactive enzyme or overactive enzyme. If you have an underactive enzyme, then actually more dopamine sits around and you actually have more dopamine than others. And if you have an overactive enzyme, it's the opposite. So we've actually shown that if you now go and genotype people with a simple saliva test and figure out, do they have this genetic, what we call polymorphism, where just one amino acid gets changed and the enzyme becomes either active or underactive, we can do the same thing as grouping them by their capacity. Those that have the low dopamine, we will make them better, and those who have sort of baseline high dopamine will make them worse.
Super interesting. Maybe we could talk about bromocriptine